Hello everyone, Ramya, Assistant Professor of CSC Department from Rohini College of Engineering and Technology, Subject Code OMD 551, Unit 4, Topic Temperature, Respiration Rate, Pulse Rate Measurements. Objective to learn about the concepts of body temperature and their measurement. Temperature measurement. Here, the body temperature is one of the oldest known indicators of the general well being of a person. Here, we have two basic types of temperature measurements are systematic temperature measurement and skin surface measurement. First, we are going to see the systematic temperature. It is the temperature of the internal regions of the body. Here, the temperature is maintained through a carefully controlled balance between the heat it should be generated by the active tissues of the body and the heat lost by the body to the environment. Here, the systematic temperature is most accurately measured at the tympanic membrane in the ear. Here also, it should be controlled of the body is located deep within the brain, warm, cooling, ambient temperature, production of perspiration due to segregation of the sweat glands and increased circulation of blood. Here it is the only deviation from normal temperature control is a rise in temperature called fever. Here at the beginning of a fever, the skin is often pale, dry and shivering usually takes place. So then the skin and the muscles react to the coolness. At the conclusion of the fever, as the body temperature is lowered to normal, increased sweating body heat is eliminated. Next, we are going to see the measurement of systematic body temperature. It is still the standard method or measurement. Here in this devices are expensive. In these devices are inexpensive, easy to use and we have sufficiently accurate. Here also we have two types of electronic temperature sensing devices that are found in biomedical applications. First one is thermocouple. Here a junction of two dissimilar metals that produces as output voltage. Nearly it is proportional to the temperature at that junction. It is with respect to a reference junction. The next one is a thermistor. That means a semiconductor element whose resistance varies with the temperature. It is also used more frequently than thermocouples because of greater sensitivity. Here it is also variable resistance device formed like disc, beads, rods or other desired shapes. Here also it is manufactured from mixtures of various elements such as nickel, copper, magnesium, manganese, cobalt, titanium and aluminium. Here we have the resistance Rt1 of Thermistor at temperature T1. It is determined by the equation Rt1 equal to Rt0 e power beta into 1 by T1 minus 1 by T0. Here Rt1 represents the resistance at temperature T1. Rt0 represents resistance at reference temperature T0. E is the base of natural algorithms. Here beta represents the temperature coefficient and T1 represents the temperature at which measurement is taken. T0 is the reference temperature. Then the next one is your skin temperature. It is a surface or skin temperature is also a result of a balance. Here but the balance between the heat supplied by blood circulation and cooling by conduction, radiation, convection and evaporation. Next we are going to see the skin temperature measurement. It is a function of surface circulation, environmental temperature, air circulation from the measurement taken and perspiration. Here the systematic temperature remaining very constant throughout the body. Here the system temperature measurements are frequently made by using small flat thermistor bulbs. The human skin has been found to be an almost perfect emitter of infrared radiation. It is a device called an infrared thermometer. Next we are going to see the respiratory measurement. It is a change of gases in any biological process is termed as respiration. In the human body, here the respiration can be classified as two types. First one is internal respiration. It is the exchange of gases between the bloodstream and nearby cells inside the body is called internal respiration. The next one is external respiration. That means the exchange of gases between the lungs and bloodstream inside the body is called as external respiration. Here we have consists of two phases in breathing. First one is inspiration. That means it is the process of taking in air, and the next one is expiration. It is the process of blowing out air. Then we are going to see various laws that are involved in the understanding of respiratory function. First one is Boyle's law. It states that at constant temperature, the volume of gas varies inversely with the pressure. That means if volume is increased, pressure falls down. When the volume is decreased, the pressure increases. Next one is Charles' law. It states that at constant pressure, then the volume of gas is directly proportional to the absolute temperature. Then the next law is Henry's law. It states that if the temperature is constant, then the quality of a gas that goes into a solution is directly proportional to the partial pressure of the gas. The last law is Dalton's law. It states that the total pressure exerted by a mixture of gases that is equal to the sum of the partial pressure of various gases. Next, we are going to see the instrumentation for respiration measurement. That means it is the mechanics of breathing can be derived from measurement of lung volumes at various levels and conditions of breathing, pressure within the lungs and thorax with respect to outside the air and instantaneous airflow. Here first method is spirometer. It is the most widely used laboratory instrument for respiratory volume measurements is the spirometer. It is mostly possible to determine all lung volumes and capacities by measuring the amount of gas inspired or expired. Here also we have some vital capacities. Forced expiratory volumes can be performed on a spirometer. Here it shows, the figure shows the spirometer. That means a spirometer cannot able to measure volumes, capacities. It requires the measurements of the gas that cannot be expelled from the lungs. Such measurement includes the residual volume, functional residual capacity and the total lung capacity. Next we are going to see the measurement of residual volume. That means from the spirogram and the outputs of some of the other requirements, all the lung volumes and capacities can be determined except those that require measurement of the air remaining in the lungs and the airways after maximum expiration. The next one is a closed circuit technique. It involves breathing from a spirometer which has a known volume of air with a fixed concentration of helium gas under the inverted bell. For example, the patient is made to breathe this air for a considerable period, so the complete mixing of gas in the spirometer and the lungs can be measured. Here the diagram shows that diagram washed out technique. That means it involves the inspiration of pure oxygen and expiration into a spirometer. That means the oxygen in the inverted well. Here we have almost 78% of nitrogen remaining in our lungs. The next one is intra-alveolar and intraotheric pressure measurements. That means it is an airtight box in which the patient is made to it. Here the patient breathes air from within the airtight box through a tube provided inside the box. Here we are using some conditions, that is the sum of the air inside the box VB and air in the lungs of the patient VP, that is intrathoracic volume. So V total equal to VB plus VP. On small change we get del of V total equal to del of VB plus del of VP. But del of V total equal to 0 as airtight box is, it means what happened? Del of VB equal to minus del of VP. As per Boyle's law, you will get VPP equal to endothoracic pressure. That means del VPP equal to minus del VP. Next we are going to see the airway resistance measurements. It is determined by the simultaneous measuring intra-alveolar pressure and it is in the airflow in the body. So the airflow resistance can be given by the relation of R equal to PIA minus PATM divided by F. So R is the airway resistance, PI is the intra-alveolar pressure, PATM is the atmospheric pressure, F is the airflow. Next we are going to see the pulse measurement. When the heart muscle contracts, here the blood is injected from the ventricles and a pulse of pressure is transmitted through the circulatory system. Here first method is transmittance method. Here the LED and photoresistors are used in this method. That means they are mounted in the enclosure that fits over the tip of the finger. Then the light is produced by the LED. Here the same light is passed through the finger. So only for each heart pulse, blood is forced into the extremities and the amount of blood in the finger is increased. So optical density is changed. Then the light is received by the photoresistor. The next method is reflectance method. In this method, the LED is placed adjacent to the photoresistor. So it emits the light and this light is reflected from the skin. Then the tissue falls on the photoresistor. So it is connected as part of the voltage divider circuit. The output can be recorded using strip chart recorder. Thank you.